topic is measurement of capacitance. We have discussed previously measurement and of impedance and using Maxwell bees and Hayes bees. Then today our topic is measurement of capacitance. First of all, we use Sauty bees for measurement of capacitance. So what is the circuit? First of all, there are the 4 point A, B, C, D. Between A and B there is a capacitor. This capacitor is C1. B and C there is a resistance. This is denoted by R3. Between C and D there is a resistance R4, and between A and D there is a capacitance. This capacitance is C1. A and D, the voltage here is denoted by E2. The voltage between C and D is E1, B, and A and B there the voltage is E1, and here B and C the voltage is E2, and the supply voltage is between total is E. So if we draw the phasor diagram of it, first of all the I1 I2 is in phase, and the direction of E3 and E4 means I1 R3 is equal to I2 R4, and the capacitor is lagging 90 degrees, so here E1 is equal to E2 is equal to I1 by omega C1 equal to I2 by omega C2. So if we take the resultant E, it is given by, so from the circuit for balancing we know Z1 Z4 is equal to Z1 Z4 equal to Z2 Z3. So we have capacitance, there is the equivalent omega C1 multiplied by R4 equal to omega J omega C2 into R3. So if we calculate, we that we get that C1 is equal to R3 C2 R4 by R3. J omega is cancelled, so C1 equal to C2 R4 by R3. This is the equation of this Sauty bees. But there are some problem if we there is a dielectric loss. So the V is simplicity, it is the main advantage, but if we take the dielectric constant, it is modification by the Grover. So how it's modification? So modification, there is a resistance A, B, C, D. A, this is B, this is C, and D. Then between C and D there is a resistance. Here there is a resistance A and B. There was a capacitor, then it was connected by a resistance. And here there is a resistance and there is capacitor. So how we calculate this similarly in previous, there will be the voltage, here is E1, here is E2, here it is E3, and here it is E4. Total supply voltage is E. Same as previous, we have drawn that the equivalent we have to calculate equivalent resistance. So how we calculate? Same formula, Z1 Z4 equal to Z R1 plus R1 by 1 by J omega C1 into R4 is equal to R2 plus R2 plus plus 1 by j omega c2 into r3, the same as bridge balance equation. Then we get equating real and imaginary part, r1 r4 plus r1 r4 equal to r4 by j omega 1 c1 r2 r3 plus r2 r3 plus r3 by j omega c2. So equating real and imaginary part, equating real part, we get um, r1 r4 plus r1 r4 equal to r2 r3 plus r2 r3, and imaginary part equal to r4 by j omega c1 equal to r3 by j omega c2. So j omega cancel, so from that point we get um, r1 by c1 by c2 equal to um, r1 by r c1 by c2. From that we get r4 by r3 c1 by c2 equal to r4. From there we get um, r4 by r3. What is we get? R4 means r1 plus r1, and here we get r3 means r2 plus r2. So equating the two equation 1 and 2, we get equating 1 and 2 equation, we get c1 by c2 equal to r2 plus r2 by r1 plus r1 equal to r4 by r3. So we get the dissipation factor d1, dissipation factor d1 equal to tan lambda 1 means omega c1 r1, and d2 equal to tan lambda 2 equal to omega c2 r2. From the equation we go c1 by c2 equal to r2 plus r2 r1 plus r1. So here we get c1 r1 plus c1 r1 equal to c2 r2 plus c2 r2. So how omega c tan lambda by tan lambda 2 we have to calculate this one. How we get the equation c2 r2, c1 r1 plus c2 r2. So if we calculate, then omega multiplied by this one equation previously, omega multiplied omega c2 r2 minus omega c1 r1 equal to omega c1 r1 minus c2 r2, equating the equation. So d2 minus d1 means we take the dissipation factor equal to omega c1 r1 minus c2 r2. So if we calculate c3 by c2, we get previous equation r4 by r3. So equation is omega c2 r1 r4 by r3 minus we get the r2. This is the equation. So dissipation factor is known from the other determined. This is the variable resistance. And the last one we use by Schering bridge. Schering bridge, how we calculate? Using Schering bridge, there are the similarly C A B the point, there is a capacitor C1, there is a resistance R. Between B and C there is a resistance R3, A and B, D there is a capacitor C2, and here the capacitor is C4 between C and D. So C and D there is another resistance, this resistance parallel R4. So if we take equivalent supply voltage, total supply voltage E, and between and D same as previous. The voltage, and the voltage is E1 and the voltage is E3. If we calculate and balancing, there is a detector D. So if we calculate, draw the phasor diagram, I1 is the in phase, and I equal to IC in, and I1 R1 is the lagging current, I1 by omega C1, and the E1 E1 is the dissipation factor lagging by E1 equal to E2 equal to I2 by omega C2, and E3, that is I1 R3 in phase, this is I4, this is I2. So total E equal to equivalent resultant vector this and this will drop. So what is the equation for balancing R1? There is capacitor is series, so R1 by omega 1 by j omega C1 multiplied by R4, capacity is parallel, 1 by j omega C4, 1 plus R4 by j omega C4 multiplied by R3 into 1 by j omega C2, capacitor is parallel. So how we calculate, and R1 plus 1 plus j omega C1, R1 by j omega C1, here we get R4 plus R4 plus j omega C4 equal to R3 by j omega C. So from here we separating the real part and imaginary part. J omega is cancelled. So you will get R4 plus j omega C R4 C2 j omega C1 R1 C2 into R4 equal to R4 R3 C1 plus j omega C1 C4 R3. Equating the real part and imaginary part, we get j R4 C2 equal to R4 R3 C1, so C2 equal to R3 C1, and small real part and imaginary, j omega C1 cancel, R1 C2 R4 equal to C4 R3. So from that we get R1 equal to R3 C4 by C2. So these are the equation. So D1 transmission factor 10 lambda equal to omega C1 R1, we get omega C1, we put the equation here, and C4 we calculate omega C4 R4. The value of here we get the capacity.